This is the 12.1 mini lesson on circles and polygon relationships. So we're going to use this circle to answer each question. First of all, the definition of a circle is it's a collection of points on the same plane, equidistant from the same point. So all of these points are the same or equidistant from point B on the same plane. And the center of the circle is the point from which all points on the circle are equidistant. Circles are named by their center point. Remember, points are always capital letters, so this would be called circle B. Okay, the radius of a circle is the line segment formed by connecting a point on the circle and the center of the circle. Diameter is the line segment formed by connecting 2 points on the circle, but here's the clue here. It has to go through the center point. So they want us to identify a radius. So any one of these would be considered a radius. So remember, a radius, it's a segment. So I'm going to say FB. So radius, and I could put the little segment symbol above. So there would be many. When they want me to find a diameter, I could look here all the way to here, straight across. So it's D to E. And again, it's a segment. I could have taken, in this example, F to G. Now, even though it goes through B, I never use 3 letters. A segment is identified by the 2 endpoints. So I could also have said FG. So all the radii on a circle, and this is the plural for a radius, so all the radii of this circle, are they all the same length? And yes, because they are all the same distance from the center. So all radii of a circle are congruent. And then what's the relationship between the length of the radius and the length of a diameter? Well, the diameter is twice the radius, or I could say the radius is half the diameter. Okay, so recall that congruent means the same size and shape. So if circle A is congruent to circle C, what can we conclude about the radii in circle A and circle B? Well, then the radii must be the same length. And if circle A is congruent to B, what can we conclude about the diameters? Same thing. The diameters must be the same length. So now Dion knows circle D is congruent to circle E. Why does she know that? Well, if I look at the radius of circle D, the radius would be DE. And if I look at the radius of this circle E, the radius is also DE. So if the radius is the same, then we know the circles are congruent. Same radii. The circles must be same size or congruent. So now we're going to look into polygons. Mr. Graham was explaining to his students how circles are directly related to polygons. The class was discussing how circles do not have sides and polygons have sides, so it was not clear to them how circles and polygons had much of anything in common. Mr. Graham told his students to use only their compasses to try to discover a relationship. Jeff discovered he can construct an equilateral, remember that's the same side lengths, triangle using two congruent circles. Here's what he drew. Jeff's work shows, or we want to complete Jeff's work to show the equilateral triangle. Well, I know that this is the radii of circle A, and I could go right here. That's a radii of circle A. This is a radii of circle B, and this is a radii of circle B. So all three of these side lengths are the same length. We made an equilateral triangle. So Jackie says she can construct an equilateral quadrilateral. So same side lengths, but there will be four sides using three circles. So let's complete the work to show it. So this is a radii of circle B. This is a radii of circle B, so I know those are the same. This is a radii also of circle C. This is a radii of circle C. So those, all three then have to be congruent. This is a radii of circle A. This is a radii of circle A. So those two have to be congruent. So then all four side lengths must be congruent. So if we look for some relationships, it took us two circles to make a regular, meaning sides are the same length, polygon that was three-sided. With three circles, we made an equilateral four-sided figure. With four circles, I should be able to make a pentagon with all the sides the same length. With five, I should be able to make a six-sided figure or a hexagon. And with six, I should be able to make a seven.